Alright, so in this video we're going to be looking at probability density functions. So let's get started. So what exactly is a probability density function? Basically, it's a function that for every x value will provide the relative likelihood of that event or condition occurring. So the total area under a probability density function is always 1, and that is because the chance of at least one of the possible events or conditions occurring is certain. So many probability density functions that model natural phenomena take the shape of a bell curve. So they look kind of like this. You'll see most of the data points are in the middle, are grouped in the middle, and that's what a bell curve or a normal distribution looks like. So oftentimes, for example, things like height, things like test scores, cholesterol levels, and machine error, they are modeled using this kind of normal distribution. And so probability density functions can also look like this. And this kind of probability density function is used to model waiting times. So basically, the longer you wait, the more likely you are to be first in queue. So as time goes on, you're less likely to wait. So yeah, this is a waiting time probability density function. So let's get into the example. So here we have the random variable x has a probability density function given by this. So f of x is equal to an arbitrary constant times 2x plus 3 over the interval -1 is over the interval -1 to 2. Otherwise, it's always 0. And we have to find k. So to solve this problem, we're going to have to revert back to one of the fundamental properties of probability density functions, and that is that the total area under the probability density function is always 1. So that means if we take the integral of this function over this interval, it's going to be equal to 1. So let's set that up. So we've got the integral from -1 to 2 of the function is going to be equal to 1. Okay, so we're going to plug the function in. So the integral from -1 to 2 of 2x minus 3 dx is equal to 1. And then we're going to go ahead and solve we're going to find the antiderivative, and we're going to plug that in from -1 to 2. So there we are. If we solve that, we get 12k equals 1, and therefore k is equal to 1 over 12. So I'd like to thank you guys for watching, and hope you have a good day. Be sure to like and subscribe.